We could potentially have an active start to the new year on around the 7th, plus or minus a couple days. I am looking at the 500 millibar level. There is a negatively tilted trough displayed by the GFS. This is on the 7th evening time around 7 p.m. Central Time. So I've noticed this consistent trend with both the GFS and the Euro having some sort of trough in the Western United States developing. So here is the latest model, and then here is the trend. Here's what I'm talking about. See, you got this one right here, and then this is this model run is from the 28th to 18Z, so it's a couple days old. And then right here, way out back to the west of California, showing up right here over Mexico, and it just continues on. So there's going to be something. It's just a matter of when, what it is, how severe it's going to be, and pretty much every question you need to answer in a forecast. Unfortunately, we don't have that right now. We just have the signal of there's going to be something. And then here is what the Euro model is looking like right now as well. Same time frame, just showing different model runs with a different model as well. Here's that trough again. It's a closed upper level low. Showing up right here again over California, and it just continues to show up. This one, it's in line with what the GFS was showing. It just has the trough way out west. And again, it's right here as well. It's continually showing up. Now, what I don't like is how the model disparity between both the GFS and Euro, they're not lining up like they were earlier. Like, for example, this latest model run has this really weak, positively tilted trough that's going to be an indicator of like a fast moving system that's not really as active as a negative tilt would be. So we have those hints like, hey, there's going to be something. You might want to take a look at this, and that's exactly why I'm looking at it so far out in advance. Typically, I don't usually like to look at stuff this far out, but I do think that this could be an eye-opening way to start the new year. Now going back to the GFS, this is the 850 millibar level. This is the same time frame as what I was showing with the 500 millibar, but we're going to advance a little bit and see exactly what the low-level jet's doing as this system progresses. So the low-level jet does ramp up quite a bit. 12 hours, like at the beginning of this forecast period that I'm doing, it's 40 knots, give or take, and then in just 12 hours, or 6 hours, goes up to 55 knots, and it maintains that strength. It weakens just a little bit, but it's not enough to be a significant weakening. So it keeps that same strength over the next 24 hours or so, and actually strengthens way over in Minnesota, but that's too far for me to for a comfortable forecast. So just gonna stick with this time frame here. But yeah, the low level jet does pick up a little bit, getting some enhanced moisture return from the Gulf. Really ramps up over Kansas and just continues to be over Kansas. Again, this is one model run. Several different model runs are showing a different thing. So this forecast will transform. It will morph into something completely different by the time this forecast period rolls around on the 8th. It might be nothing at all. We don't know yet. But this is just what I'm working with right now, and this is what I'm going to be showing you. There's quite a bit of consistent relative vorticity over the Kansas-Oklahoma area, even portions of North Texas, and that just remains in the area as this low begins to move northeastward. Obviously, there's going to be the most amount of spin at the center of the upper level low, but just out ahead of it, that is where we're going to be seeing a lot of the action take place, whether that's severe storms, winter weather, stuff like that. So it's a consistent pattern that remains in that same area over a good period of time. And so that is why I'm thinking that this is something we need to keep an eye on, because with relative vorticity, that means that it's going to, it's a good indicator that there's a lot of upward motion. What relative vorticity does, what it means is that there is some sort of cyclonic spin at 500 millibar level. At the 500 millibar level, that is also known as the level of non-divergence. So there's no upward motion, there's no downward motion, obviously in a vacuum where weather's perfect. So meteorologists and forecasters use that level to identify where the spin is happening, because there's no upward or downward motion, there's no divergence, no convergence. It's just stagnant. So if you have that cyclonic spin, you're going to have that upward motion, because cyclonic means counterclockwise, and then if you go from the surface up, you get that upward motion. Anticyclonic is the opposite, you get downward motion. So with that cyclonic spin we got going there, upward motion, maybe some divergence aloft, creating that vacuum effect needed for deep moist convection. A big part of why I'm not writing this off is because of the surface-based CAPE. It just constantly shows a little bit of CAPE occurring in any sort of time frame. And if it didn't have that CAPE consistently showing up, it would be a different story. It would be nothing. It would be probably really windy, maybe some snow, stuff like that. But we're not getting that. We're having that CAPE that's needed for the upward motion to really take off. So we get a little break in that CAPE here, and then it shows up again as that low pushes through. You can actually see the development of that front, really sharp, clean edge right here. But yeah, I want to write it off, but I can't because of that. I need to find reasons why it won't happen, why a weather event won't happen, and this is one of those supporting factors that it will happen. So again, it's just hard to write off. Euro is doing the same thing too. We got this CAPE that starts to show up. This is mixed layer CAPE. Just shows up. It's very weak, but it's there, and that's what matters. We need just a little bit of CAPE to cause at least a severe thunderstorm to happen. No CAPE, no severe thunderstorms, no thunderstorms in general, really. Going a little farther out, we got some increased CAPE levels at over Louisiana. So, and then boom, this is later on in the forecast, but again, it's that signal of something might happen. Something severe could possibly happen. Now, if we look at the bulk shear, it's again supporting that cause of there could be an active weather pattern happening. You need to have 35 knots or more to cause supercells, and we definitely have a lot more than that. We got up to 73 knots of wind shear. What wind shear is, it's the sum of what the wind speed and direction is at the surface, and adding that to what the wind speed is at 500 millibars. And so you got those two together, and you got what the wind shear is. It's a shear vector, and so that's pretty much showing how much rotation there is in the atmosphere. Not necessarily how much rotation there is in a storm, just it's showing the background of what a supercell needs to develop. And we got quite a bit of healthy shear showing up right now on the GFS. It's also on the Euro model as well. It's just more of a blanket coverage, and I do think that it's a bit over forecasted. I'll show you here in a little bit. But in the meantime, though, the supercell composite from the GFS is showing that signal that something could develop in the severe side of things. I mean, given it's not that high of a supercell composite, 4 isn't that high, but just the fact that it's there this deep into winter proves that there could be an unseasonable active pattern of weather coming in our near future. And then here is that bulk shear that I was talking about with the Euro. It's like I said, pretty widespread. I do think that the overall size of the intense shear is a bit over forecast, but I do not think that the intensity is necessarily over forecast. It's just a matter of the placement and the timing of it all, given the fact that the GFS also has some pretty high shear values. It's also really common to have high shear values in the winter because the jet stream dips down quite a bit over into the Gulf area, whereas in the summertime the jet is more it's more northerly, and so you're not going to have that much shear because there's not as much interaction between the surface and the jet stream. So intensity is there, placement and the widespread nature of it all, I do think is a bit over forecasted. No, I was on Pivot Weather before. Now I'm on Tropical Tidbits. Um, just different websites show different parameters of each model. I'm looking at the EPS, which is the Euro version of the ensemble forecast. Pretty much, there's tons of ensemble members that come together and create a consensus forecast for me. So right now it has the low pressure on the surface, the center, right over southeastern Colorado, uh, over by the Panhandle of Oklahoma as well, and all these really pretty colors of the rainbow shows that wavy pattern that's needed for whether to an active pattern to develop. And we have that right now. We have that trough. That's a pretty large trough in terms of just how wide it is from west to east. It doesn't necessarily mean that it's intense, just that it's there. And so got that trough right here, got that low pressure center right on the cusp of the trough axis, which is where we want it to be for an active weather pattern. And it just continues on over into the Great Lakes and off into the Hudson Bay. So, oh wow, look at that intensity! Like the shortwave pattern starting to intensify too. Could have some more active weather behind it, possibly. We'll see. But yeah, so we have this pattern change happening over the next coming days. And I do think that we will have an active pattern of weather, whether that be severe weather, tornadic weather, winter weather. That is still to be determined. So keep updated with your local meteorologists in the area. I will continue to be posting forecasts as well as this system approaches.